Given a quarter circle inscribed in a square. Required to find the area of the red region. Intersection theorem, Pythagoras' theorem, area of a square, and quarter circle are used to solve this question. Two methods will be used to find the radius of the quarter circle. Method 1. Label points D, Q and G. Locate the center O and join line O, G. Line O, Q equals radius, R of the quarter circle. This implies that line O, D equals line O, Q minus line D, Q, which equals to R minus 4. Also, line O, G equals R. From right triangle D, O, G. Using Pythagoras' theorem, the square of O, G equals the square of R, which equals the sum of the square of O, D and the square of D, G, that is, the sum of the square of R minus 4 and the square of 8. Expand bracket and combine like terms. This implies that the square of R equals the square of R minus 8 times R plus 16 plus 64. Divide the equation by 8. We have that 8 times R equals 80. Hence, R equals 80 divided by 8, which equals to 10 units. Since O, Q equals R, which equals to length of the square. This implies that area of the square A equals the square of R, which equals to 100 square units. Hence, area of the quarter circle A1 equals to 25 pi in square units. Therefore, area of the red region equals to 100 minus 25 times pi. That is, 25 times, in bracket, 4 minus pi. In square units. Method 2. Complete the inscribed circle in a larger square as shown in the figure. Label points K, J, H and E. Line O, H equals R and H, D equals R plus R minus 4. Which equals 2 times R minus 4. K, D equals G, D. Which equals to 8. It is because they are congruent lines. Using intersection method. K, D times G, D equals Q, D times H, D. Substitute values and we have that 8 times 8 equals 4 times 2 times R minus 4. This implies that 64 divided by 4 equals 2 times R minus 4. Therefore, 2 times R equals the sum of 4 and 16. Which equals to 20. Divide both sides by 2. R equals 20 divided by 2. Which equals to 10 units. Using intersection method. The product of length of line K, D and line G, D equals the product of length of line Q, D and line H, D. Substitute values and we have that 8 times 8 equals 4 times 2 times R minus 4. It follows that 64 divided by 4 equals 2 times R minus 4. Therefore, 2 times R minus 4 equals 16. The area A1 equals quarter of pi times the square of R, which equals to 25 times pi. In square units. Therefore, area of the red region equals a minus A1. Which equals to 25 times. In bracket, 4 minus pi. In square units. After factorization of substituted values.